Hello. As mentioned earlier, my name is Jeff, and I'm going to demonstrate for you how to use the equipment in the Hydropower and Water Experiment Laboratory for San Jose State University's Engineering 10 class. Right here, we have the setup for the first part of the experiment. For the first part of the experiment, we have the upper reservoir sitting on top of the large tables, the two-tier desks. And we have the lower reservoir sitting down here at the bottom. Inside of the bucket, we have gallon markers, and we have a pump to pump the water from this lower reservoir to the upper reservoir. It's very important that whenever you go to move the upper reservoir, that you make sure to completely drain the upper reservoir into the lower reservoir before attempting to move it. To begin the experiment, you have to first connect your turbine to the upper reservoir. In order to do that, we have a three-pronged, three-valve setup on these turbines. And then we have an electrical tip that will be used to measure the outputs from the turbine. The valve on a turbine, when it is in this position, perpendicular to the fitting, that means this particular branch is off. When you see the valve moving in the direction of the fitting or in the direction of flow, it means that the valve is on. It is very, very important that you should have all of your valves turned in the off position on the reservoir and on the turbine whenever the setup is being used. Here you can see one of our spillway hoses connected to the reservoir. The way it works is by using what's called a union, and there should be a little black rubber O-ring. All you have to do is take the large end and attach it to your turbine like that. You just want to turn it until it's tight, and then you want to hold at the base, give it just a little tiny bit of a twist more, and that's all it takes. It doesn't require Superman to tighten these. You don't need to tighten them until your hands are bleeding. Just a little twist past that initial tightness is all that you need to create a tight seal. Once you've connected the union onto the turbine, we already have one connected. The first part of the experiment, one is all that you're going to need. You're going to take your turbine, you're going to grab the other end of the hose. You're going to take it, and you're going to have one member of your group hold the flow end of the turbine inside of your bucket. Now you want it, it'll slip right over the bucket, just like that. You want to have somebody hold it right at this point. You want to make sure that all of your valves, as seen here, are in the off position. They don't have to be perfectly perpendicular. You can get most of the way like that and it'll be completely off. While one member of your group is holding it, the other member of your group will affix the other end of the union to any one of the spigots that come off of the upper reservoir in the exact same manner we discussed earlier, just till it's tight and just a little twist more. Now, once you have your upper reservoir connected safely to your lower reservoir, what you're going to need to do is fill this pipe with water. In order to do that, you're going to have one person open the bottom valve and make sure that the water is flowing into the bucket at all times. And somebody else will open the upper valve that is connected to your hose. And if we come take a look in the bucket, and as you can hear, we have water flowing. With an individual pipe, it's very easy to fill it with water, but as you can see, if you look here, there's a little bit of air right there that sits in the pipe. You want to try and get as much air out of the system as possible. This can be done by temporarily lowering the level of this into the bucket and making sure that the air always has a lower potential to go to until it travels all the way through the pipe and up into and out the top of the reservoir. Once you have the water flowing through your pipe and you have the air out of the system, you will turn off the bottom valve to prevent the water from flowing out of your system. At this point, your system is fully charged and it's been what's called bled. All the air is out of the system. And now what you need to do is you need to take your pump, you need to plug it in, and you need to fill the upper reservoir. Now I've already pre-charged the upper reservoir. So all I need to do is get the water that was in the lower reservoir into the upper reservoir. Making sure that this tip of the hose is not inside the water surface. Now you won't be able to see it or how full this upper reservoir is while it's up here. That's why on the inside there are water marks. And there's going to be a mark on the very bottom. That lowest mark on the reservoir is where you want the water level to sit. When the water level is sitting at the lowest mark inside of your lower reservoir, that means that your upper reservoir contains 3.5 gallons of water. This is the entire setup procedure that you need to follow when setting up this laboratory. When it comes time to set up the second part of the laboratory, you'll have to move the upper reservoir to a lower space. In order to do that, you're going to have your valve open here. You're going to open the same one you've been using the whole time. You're going to just let the system run until it's completely out of water. This will take about 5 to 6 minutes. For stage 2 of the experiment, we're going to simulate a real-life situation. Most specifically, we're going to simulate having a dam. In order to simulate a dam, what we're going to do is we're going to move the upper reservoir after it's been completely drained into the lower reservoir to one of these tables. Once you have the lower reservoir at this table, you then will charge it up in the exact same manner that you did the first stage of the experiment, so that the water inside of here is sitting at approximately 3.5 gallons. Now, what you're going to want to do for this experiment is you're going to have the goal of optimizing power output from this dam while minimizing the amount of flow rate you use in either gallons per minute or cubic feet per second, whichever one you prefer. So what we're going to do for this experiment is we're going to hook up different amounts of tubing, which is going to simulate a spillway of a dam, to the turbine. And then from this experiment, you can check and see how much power you generate when you have an individual spillway open, 2 spillways open, or 3 spillways open on an individual turbine. You'll notice that each group is actually given 2 turbines. This is because you can connect multiple turbines to an individual dam. What this different setup allows you to do is what is done in a real dam. In a real dam, turbines can't generate an unlimited amount of energy. They have a ceiling, a max cap of power generation that they can get. The same thing is true of these little tiny turbines. So many times what's done is you will connect many different hoses to many different turbines, and then you'll add up that total amount of power, and that will be the power generated by a dam. This also allows you to control the amount of power you're generating, because you don't always need to be generating a full amount of power all the time. The constraint is that you cannot surpass 0.4 gallons per minute. You will measure this using the exact same technique that we used in stage 1. And you'll do it for each experimental setup to make sure that you aren't violating the 0.4 gallon per minute flow rate that we've set for this experiment. What this is going to simulate for you is that there is only X amount of water. And that water in real life comes from all the different snowpack and rain that flows into any given dam over the year and sets the level of water that you have to send downstream to meet demand. Now that you know how to set up the 2 experiments for this laboratory, I'm going to show you how you actually collect the data with the help of Armin, the TA for the E10 laboratories. So what we're going to do is we're going to use a digital multimeter. And we're going to take these 2 probes and we're going to connect them to our turbine in order to measure the current and the voltage. What you do to connect the multimeter to the turbine is you're going to take the red probe, or the positive probe, you're going to put it inside the tip of the connector that comes off of your turbine. You're then going to take the ground, or the black probe, and you're going to hold it on the sheath for the turbine. Once you have it held in this position, or any other way that you want, as long as you've got these two things touching, you're going to have the person in charge of manipulating your turbine, in this particular case Armin, turn on the flow of water. So if you could do that for us, Armin. All right. Now, once the water is flowing, you're going to take several measurements, which I'll show you in a second. You only want to leave it running for about 10 seconds for each measurement, and then turn it off. So if you can turn that off for us, please. Once you've turned the water off, you'll turn off your multimeter, and you will pump the water you just drained from the upper reservoir back into the upper reservoir, and you will repeat all of these steps again in order to get your reading of the voltage and the current, which I'll show you now. Now that your system has water flowing through it and you've got your digital multimeter connected correctly, if you look down here, you'll see that it's giving me a reading. And as you can see, the reading goes down over time as the water drains out. So once it reaches its first steady equilibrium state, you're going to want to press the hold data button that can be found on most digital multimeters. If your digital multimeter doesn't have one, as soon as you get a steady value, make sure you have somebody in your group ready to write that value down. You then repeat the process for the current.